we're going to continue on. This time we're going to start with polar equations, then we're going to convert them to rectangular equations, and we're going to graph. And just like before, we're going to graph based on what's convenient, not necessarily what you... Basically, you're going to say, all right, which one of these makes the most sense? And so like for this one, I think the polar equation makes more sense. Maybe you don't, but I do. R equals -1. Now, what this says is that no matter what angle you're at, the distance is always 1 in the opposite direction. So if I'm at an angle of 0, it's -1. If I'm at an angle of pi over 4, it's -1. If I'm at an angle of pi over 2, -1. If I'm at an angle of 3 pi over 4, -1. So what you're seeing is no matter what, I'm a distance of 1 away. So I'm really just drawing a circle that has radius 1. Which you might expect is, okay, well then that equation is going to be x squared plus y squared equals 1. Now that's true, so the question is how do we prove that? Well, what we do is we take this equation, we have r equals -1, so we also know that r squared must be +1, right? That's the rule. But we know that r squared is x squared plus y squared. Boom. Now you might say to yourself, well, this is a lot easier. If I saw this, I could draw that graph. And that's probably true. But as you get more familiar with polar graphs, I think you'll find that it's probably pretty equivalent. The next one, I think since you're starting out, I think it's going to be a lot easier to convert this to rectangular first. But once you get familiar with polar, it's not too bad to stay in polar. So we say, okay, how do I solve these types? Now this one is always tricky. People always forget the best way to do this. The easy way to do this is not to square things. If you square things, you're, nope, bad. Over here, you saw an R and you say, I squared it. If you square this one, it's not going to get you anywhere. The key for this one is to multiply both sides by R. So I have R equals 7 sine theta. If I multiply both sides by R, I get R squared equals 7R sine theta. Why is that important? Well, it's important because once I have an R sine theta, I can turn it into a Y. So now I have x squared plus y squared equals 7y. Okay, that's not bad. So then what I have to do is I have to get everything on one side of the equation. X squared plus y squared minus 7y equals 0. Now for this type of problem, what you're going to want to do is you're going to want to complete the square. So you take this number, you cut it in half, which is 7 halves, and you square it. So you say x squared plus y squared minus 7y plus, so then 7 halves squared is 49 over 4 minus 49 over 4 equals 0. Now you might ask yourself, why in the world would I do that? The reason you want to do that is because then you're going to write x squared plus y minus 7 halves squared. So that's what this is. This is set y minus 7 halves squared. And then I'm going to add this to the other side, equals 49 over 4. So that you're pretty much done. You could also write that as x squared plus y minus 7 halves squared equals 7 halves squared. The reason you might want to do that is that tells me my radius is 7 halves. And my center is also at 7 halves. Or at 0, 7 halves. So my center is here. And then my radius is also 7 halves. So I go all the way down to the bottom up to, that would be 0, 7. And that's the graph. The reason why I say in polar, it may make more sense. What's nice about the polar case, if you do this in polar, is that everything that's some sort of number times sine of theta looks exactly like this, and the number tells you how high it goes. So for instance, if this was 5 sine of theta, it would look just like this, except it would go up to 5, and the center would be at 0, 5 halves. So if you know you're polar, you don't have to deal with like these kind of nasty things and completing the square and stuff. You can just straight plot it. And then, by the way, the cosine versions, instead of being here, they're out here. But it's the same type of graph. So knowing your polar equations here can be really helpful, really convenient. Because who wants to deal with halves and completing the square? Yuck, right? Anyway, our final one, I think it's definitely easier in polar, but again, you tell me. Theta equals pi over 6. So what you do is you say, okay, well, what's pi over 6? Pi over 6 is about this. And you're done. Okay, well, I mean, it's not quite pi over 4. This is actually probably a little too high. But it's pi over 6. Because it's just saying, what's the case for any length of r? It could be short r, long r. The theta is always the same. So you're just pi over 6. That's it. Right? And so if we want to convert this, though, what we have to do is we have to use this relationship. You have to say tangent of theta is equal to y over x. So now I say tangent of theta is tangent of pi over 6, which means y over x is tangent of pi over 6, which I believe is the square root of 3. Right, is the square root of 3. So if tangent of pi over 6, no, it's 1 over the square root of 3. Thank you for catching me there. Tangent of pi over 6 is 1 over square root of 3 because it's 1/2 divided by square root of 3 over 2. And so then what you say is y is equal to x over the square root of 3. And that's your answer. So, and this wouldn't be terrible, but it's kind of nasty to plot versus if you just figure out what pi over 6 is, you can draw a line straight through it. So generally speaking, theta equals a number, I think is easier to graph polar. R equals a number is easier to graph polar. This, I still think is easier to graph polar, but I can see where some people wouldn't. So again, do some examples, get some familiarity under your belt, and you'll be good to go.